All right, here we go with iChem lesson 24 on basic heat flow. Okay, essentially, heat flowing into and out of a system can cause temperature changes. And I just want to emphasize for now this word can. Doesn't necessarily matter for today's iChem, but later on this week, this idea of can will come important. Heat being added or taken away doesn't necessarily change the temperature. In this case, though, we're going to look at what happens when it does. Okay, so the factors that are affecting the degree of temperature change are how much heat flows in and out of the system, how big the sample is, how much mass it has, and how easily the substance changes temperature. So the equation that the key equation for this is Q equals mc delta T. Calculates the relationship between heat and temperature change as well as the factors we just mentioned. So Q is the amount of heat flowing into or out of the sample. Its unit usually is in joules. Sometimes you'll see it in calories, like we talked about the other day. The mass of the sample will have units of grams, as we know. The specific heat capacity of the sample is something we haven't really talked about yet, and it's a constant that is specific to every substance. Essentially what it represents is how easily the substance will change temperature. The higher the specific heat, the more energy is required to change the temperature of the system. And I'll give you some examples of this so you can sort of wrap your mind around it tomorrow, or we'll look at some examples. The units are joules per gram degree Celsius, and sometimes instead of joules again we'll see calories. And the fourth variable is delta T, which is change in temperature of the sample. It is very important to note the units are degrees Celsius there. It is very important to note that temperature and mass are the only things that you can directly measure in an experiment. You cannot measure heat. You cannot directly measure specific heat. You can measure temperature and mass and use what we know about this relationship to find the other two pieces of information. Where delta T is, and you probably want to write this down under your delta T definition, T final, where's my pointer? T final minus T initial. The ending temperature minus where you started is the change in temperature. So here's a few examples. The first example says how many joules of heat are needed to raise the temperature of 10 grams of aluminum from 22.4 to 22 degrees from 22 degrees to 55 degrees if the specific heat of aluminum is 0.90 joules per gram degree Celsius. Remember our key equation Q equals mc delta T. What we're trying to find in this case is Q. If we look at what we have in our givens, we have M right here, we have C, the specific heat capacity of aluminum right here, and this information right here gives me delta T. Remember, delta T is the final temperature, so that will be the temperature that's heated to, which is 55, minus the initial temperature, the temperature that you're starting with, which is 22, gives you a delta T of 23 degrees Celsius. So to solve for Q, all I need to do is plug all of this into my to my equation, and then my calculator. Q equals M, which is my 10.0 grams, times C, which is my 0.90 joules per gram degree Celsius, times my delta T, which I just found here to be 23. If I multiply all of these together, I end up with Q equals 207 kilojoules. So 10 times 0.9 times 23 gives me 207, not kilojoules, sorry, just joules. 207 joules, because the unit of energy comes from the unit of energy in my specific heat here, which is joules. Let's do another example. Again, as a reminder, the equation is Q equals mc delta T. I know I need this equation because I'm talking about a change in temperature and a heat. Anytime you have change in temperature and heat involved, you're talking about Q equals mc delta T. Now let's look for what we're trying to find here. Let's give an example, and we can go through and highlight all of our variables. We have a 1.6 gram sample. That's my mass, that's my M. That has an appearance of gold. It requires 5.8 joules of energy, so that's my Q, to change its temperature. This isn't my delta T, but it will help me to find my delta T pretty easily. And then it's asking what is my specific heat. So the thing in this equation that I'm solving for is C. So let's go ahead and plug in everything I know. Q is 5.8. M is 1.6. C is what I'm looking for. And delta T I have to find. Delta T is final, so the temperature is heated to, which is 41 degrees, minus the initial temperature, which is 23. 41 minus 23 gives me 18. So my delta T equals 18. That's what goes here. 18 degrees Celsius. Okay. So now I want to solve this equation for my C. What I'll do for that, and I shouldn't have written the delta T under here like this because it's kind of going to get in the way. Let me rewrite it down here. I have 5.8 equals 1.6, and maybe I'm going to bring my 18 over. We can use our distributive property of multiplication, times 18, and then times C outside of the parentheses. So essentially, what I want to do to solve for C, you could do this math, 1.6 times 18, and put that number here if you want to, but I'm going to divide by this to solve for C. And divide by this in parentheses, so you're telling your calculator your proper order of operations. So this tells me C equals 5.8, whatever I divide by on this side, I have to divide by on this side. So C equals 5.8 divided by 1.6 times 18. And remember, put this into parentheses when you're plugging it in if you haven't already plugged in to find what that number is. You end up with 0.20, and it's joules per gram degree Celsius. Here's our last example. In this case, it's asking what is the change in temperature. So what I'm looking for is delta T. Given that the mass is 150 grams and chloroform observes 1,000 joules, that's my Q, and the specific heat of chloroform is 0.96, that's my C. So in the equation, Q equals mc delta T. What I'm trying to find this time is delta T. Plug in everything I know. Q is 1,000, M is 150, C is 0.96, and delta t is what I'm looking for. To solve for t, I have to, because it's being multiplied by these two numbers, I need to divide by these two numbers. Whatever I do for math on this side, I also have, that cancels this out, which is my goal. Whatever I do for math on this side, I also have to do over here, 150 times 0.96. So delta t equals 1,000 divided by 150 times 0.96. If I plug all of that in, I end up with 6.94 degrees Celsius. Okay. So same equation, we can solve for any number of things. We need to be given 3 pieces, and we can find the 4th. We'll do more in class tomorrow. Make sure you do your Google form.